Hey guys, let's get started. So today we'll be solving this problem, right? And you might encounter this problem pretty much everywhere. Like whichever solution which you're working on in tech, you would have to come across this problem. And what is it, right? Let's say that you want to implement a logger, right? In the cleanest ways possible, right? Let's say that you have a control room logbook in a factory where every engineer writes into the same book and nobody ever creates their own copy. Like we don't give every engineer their own notebook, right? What they must do is that they must come to the control room and they need to write to this given logbook, right? So this is a given problem statement over here, right? And we need to devise some method. We need to design some cleanest solution so that we can actually achieve this given task, right? So for the folks who are not familiar with the logbook, or like just think of it as a simple notebook where each of the engineers are just writing their update, right? And let's get started with it, right? So today we'll be dealing with the C++ implementation, and the way we are going to achieve this is using some design pattern, right? So just for the spoiler alert, we are going to be using a singleton pattern, right? So why a singleton pattern over here, right? I don't want you to spend more time just to run around the bush, because you might have already watched the video title and you might have already guessed that we will be using some kind of singleton pattern approach, right? So using a singleton, what eventually happens is that we create exactly one instance of the class object, right? So this is the first criteria of the singleton class, right? We only create the we only create one instance of the class object. Now, what is the benefit of that, right? Think of it that if each where's my thing the thing that if there is a logger, right? And then think this would be require some this will require some file handling, like actual handling it might have been requiring. So if it requires some actual file handling, what might eventually happen is that each engineers we might have some different approaches we can arrive at this, right? Each engineers have their own implementation, or you can say, or instance might be a better word, instance of a file handling. But this might be catastrophic, don't you think that this might be catastrophic? Because you are giving each engineers their own file handling, and this is basically duplicating it, right? Nothing that how bad the solution is that if there are if there are around 1,000 engineers, let's say that, then when each engineer need to call up and get their own file handling, and if something fails they may need to call this method again, and that might be a pretty bad approach. So why don't we keep a single instance, right? Why don't we keep a single instance, and whoever wants to do any kind of modification to that one, let's say to the given logbook, the given engineer can get this instance and call the file handling on this given particular instance, right? So that's just a basic idea about it, right? So this is how we come across this singleton design pattern, right? So there are a lot of things we have to do, but let's first start with the basic. Let's get the basic thing up and running. Right, so let's implement a class logger. And as we have discussed over here that would need a public over here. And since we are giving only one instance to each of those engineers, we can safely return a logger instance right over here. And yeah, so one thing which we need to do over here is that, like, think about this. This given get instance will be called by multiple people, right? This might be called by multiple people over here. So what might be the problem? What might be the usual problem which will be associated to it, right? So this given instance, like if someone is creating the instance for the first time, right? The other engineers would be calling it, right? They do not need to again construct it construct the instance from top again, right? This will be a catastrophic thing. That is the kind of thing which you are trying to avoid, right? So that's why we are using a static variables over here, right? Static will ensure that this instance is only created once during the first call, right? So this only on one object only, right? So we have achieved it, and let's quickly return the instance over here. And since we have returned the instance, what we can eventually do is that we have completed this given task over here, right? So once we have completed the given instance, what we can eventually move ahead is that now I need to come up and ask you a very basic fundamental question. What might eventually happen is that there might be multiple people who are calling this thing, right? So there might be a given race condition which might happen. Think of it, there might be 100 engineers who called this or 1,000 engineers who have called it. So if there is any race condition which will eventually happen is that when the race condition eventually happen, this instance can be called twice, right? Twice by the same thread. Or sorry, by two different threads, right? And that will be a catastrophic thing because only want one instance, one object for this given thing, right? So what you can eventually say is that okay, in C++11, whenever you use static logger instance, C++ automatically avoids any race condition which might eventually happen when multiple threads are calling this given function. So this is a thread safe implementation, right? So that take that for a note. And the next thing is that as we have already discussed that each engineer need to log something, right? So let's go ahead and log some given message over here. So we can just log a message. So as you might have guessed, right, this will be a problematic scenario, right? Why? Because eventually we want to maintain an order, right? See, the instance part, I have explained you why this is thread safe because we only ensure one instance of this is created. But whenever we are doing any logging operation, right? When engineer calls it and performs a log, at that point there might be again a race condition which might be involved, right? So we need to ensure the couple of things, right? The output does not get corrupted, right? And we are not causing any exhaustions or like, right? Couple of things around that. So for that to happen, we need to use a lock. We need to use a lock, and that's where we come up with the concept of mutex, right? So if you just use a lock guard over here along with the standard mutex, that will solve your problem, right? That will it's more than sufficient to solve the problem, and I will keep the definition of the mutex somewhere over here. So at this point you can safely assume that if an engineer has called this, we can quickly print over this message at this point, right? And once we have printed this message, let's go ahead and just also include the mutex call over here. And yep, that's completed, right? So after this, we might need to have perform further thing. So right now we don't want anyone to call the copy like the default constructor for this thing. And couple of more things is that we don't want any copy constructor associated with this thing. So what we can do is that we can safely delete that thing, and this is the required operation for that. Further, there might be a possible way where you can do operator overloading, and during the operator overloading, you can automate like default user equal to sign to assign this given logger instance, right? So we have to avoid that itself. So we will safely delete those things. Right. So just think of this as a power of the rule of three. There is again a rule of five in C++, and if you're interested, you can go ahead and read about it. But we don't want, the point is that we don't want anyone to get the instance of, like, get the object of this class, right? Whichever class needs anything, we can directly get an instance for this one, and avoid copying this overall altogether, right? So that makes it pretty threat safe in a multi-threaded environment solution. So we can quickly get some mutex over at this point over here, and yeah, that's pretty much it. So what will eventually happen is that all threads will call the get instance, and everyone gets the same object. No copies are eventually being created, and write, which eventually happens, go through a synchronized path over here, right? So this is a very beautiful implementation of the singleton design pattern, and we don't need to complicate it further, right? So uh, this is just a basic pure implementation, right? So there might be other different scenarios where you might be tempted to use the singleton design pattern, and just for the information, think of it, you might be using this singleton design pattern during the configuration manager where you want the read configs once, right? And everyone uses the same value, right? So instead of a you might have some get instance and everyone will get the same copy of the configuration itself, right? So there might be a hardware controller, right? In the hardware controller, since you have limited resources like one UART, one I2C, and so on, so multiple drivers need to share it. So again, we can have so again log card which is implemented over it, and eventually when everyone tries to get an instance, it will only get the instance of the UART and I2C. So it again avoids any complication and duplication at this point, right? So that is one given thing. So singleton, whenever you think about it, just think about is that it's like it's about an shared object, right? uh, right. So if you have a shared object, it makes things a lot simpler, right? So and if the object, and here you can always see that the object actually represents unique resources over here, and we need to coordinate the global behavior at this point, right? So the singleton design pattern will actually justify all this given thing, and it's actually a very beautiful implementation. And yeah, feel free to go around, play around with it. Yeah, right. For the folks who are in the distributed systems, they can actually use a database handling thing where you can get a single instance of the database connections, and pretty much then each of the given thread or caller might call this log information and then log the given thing on the database itself. So that's a couple of one more example which I might give to you. So yeah, that's pretty much it. So I hope you enjoyed this video, and I wanted to keep it a short and crisp so that you can come up something during the interview itself. So thanks guys, hope you liked it.